Hello everyone, welcome to the first video in this series where I will be demoing some of the more artistic projects I've done and also providing tutorials for people who might be interested in recreating something similar. In this first video I will be recreating the animation that is currently my channel introduction. So we will start off with some opencv basics. I will show how I can create this pattern grayscale effect and then proceeding into how to animate that. So I will be using Visual Studio Code as my editor here. If you do not have opencv installed, go ahead and pip install opencv-python and then we can get started. First thing we're going to do is import cv2. Then we can read our image. And then to display our image, we can just cv2.imshow, give it a title, and then the name of the image we are displaying. We're going to add one more line here, cv2.waitKey. We'll pass 0 in there. That will have the image stay on our screen until we press a key. That way it does not disappear immediately. So we can run this by python pattern grayscale.py. And we have just successfully read and displayed our image. Now to grayscale, cv2 provides that functionality. So we can gray equals cv2 dot convert color, pass the original image, and then pass what color transform we're going to do. In this case, cv2 dot color bgr to gray with the number 2 instead of other 2. So then we can go ahead and just display this image as well to show that the grayscale is working. Ta-da! Now there's a couple different ways people can grayscale. A really simple one is just to average the RGB values. It turns out you get a better grayscale image if you give certain colors a higher priority to the overall grade effect. So the conversion that opencv is actually doing, this is quite common, is multiplying each of the R, G, and B values by these constants. So instead of using opencv's built-in function, I am going to recreate this actual formula because we want to determine exactly which pixels get converted to gray and which don't. So I will actually comment this out. So first thing we're going to need is some dimensions of our image. So we can do it with the .shape method. So I'm going to type height width underscore equals img.shape. So this .shape method unpacks the dimensions in the image. This underscore here is because we do not actually care about this dimension. This is the channels. So it will return 3 for any image we give it because there's the red, green, and blue channels every time. This way, however, we can get the height and the width of the image. Then we can do some simple for loops for j in range height, and then nest that with for I in range width. So then what we can do is say the image at that location for each pixel is, we're going to actually replace it using these formula. So we'll start off with the coefficient for the red, 0.299, and we're going to multiply that by the red value at that position. One thing to know about opencv is it uses BGR actually instead of RGB. So the first index will actually be blue, so we need to be passing the third index when we are multiplying by the red because it's actually it's flipped from ordinary color spaces. So our next coefficient is 0.587, which we'll be multiplying by the first index, and then I'll just copy this one more time. Our last coefficient is 0.114, which we are multiplying by the blue, which is the very first index. And then we can go ahead and show our image after doing that conversion. And that will take slightly longer to complete because it is not as optimized as the default grayscale conversion. But as you can see, we reached the same result. Now that we have this grayscale, we can start to actually do patterns. So for example, we can say we will only do this conversion if I is greater than j. So if we run that, we have now created this line, starting from the origin, by the way, with opencv, and most image manipulation, 0, 0 is actually at the top left corner. So we've created this divider just based on that simple rule, if I is greater than j. So what we can do, if we want to create, for example, a bar down the center, we'll have a left point, and we'll have a right point. For each of these, we can just say the width divided by 2, and then add or subtract some number. So this will start with the center, and then the left point will be 100 pixels to the left of it, right will be 100 pixels to the right. And then what we can say is if I is less than left or I is greater than right, then we will conduct this grayscale operation. And we have now a colored column in the center of our image that has a width of 200 pixels. To create the circular image, however, we will need to do some trigonometry. So I'm going to import the math module. I'm going to set a radius for the image, which is just going to be the height of the image cut in half. So the actual math that we're going to do here can be demonstrated in this. So this circle is demonstrating the area that we want to grayscale within. For any point as we go through the image on this vertical axis, we can figure out where this red dot falls and use that as our left point, basically. So to do that, we need to find the angle right here. And we can do that using the cosine. So we know this is the radius right here, this side, and this is just the difference in where our height value is and the total radius. So we can, each time we move to a new j value, we can calculate theta, math.inverse cosine, and then we take the difference of r minus j and divide it by r. Once we have that angle, we can then calculate the length of this horizontal bar, which is just the difference between the center of the image and where we actually want our left and right bars to be. We can do that with another simple trigonometric function by just taking the sine of that and multiplying by theta. And then all we need to do for our left and right variables is subtract this new distance variable that we've created and add this new distance variable that we've created. So running this one more time, ta-da, we have successfully just grayscaled the inner circle here. To create an animation, we actually just need to add just a couple more lines of code. So I'm going to cut this line here, and I'm going to initialize a CV2 video writer. In this, I am going to pass a couple of parameters. So the first is just going to be the name of the output. Next is going to be the encoder, cv2.video writer underscore 4cc, and then asterisk, and then divx is what we're going to use for that. The next is the FPS parameter. So we will just set that to 30 frames per second, and then the frame size is just going to be width and height. So then what we can do is basically each time we move down a couple of pixels, we are going to take a screenshot of that image essentially and write it to this video that we're creating. So what I'll do is I'll just run this like every 10 pixels or so. So if j modulus 10 double equals 0, then I'm going to video.write and pass the image. So every 10 pixels we move down, we will take a snapshot of that and write it to this video. Since the image is 900 pixels tall, we will be writing 90 images, and since we are doing 30 frames per second, we will be creating a 3-second video. And finally, once we're done, we are going to write this video to a file, the output.mp4 that I specified above. And then I want to release video.release. So running this. So it looks like I made a syntax error here. I'm missing an equal sign. One other thing I've actually done incorrectly is this needs to be de-indented. We don't want to run this for every width. We just want to run it for each height. If we left it there, it would take forever to complete because it's going to be writing 900 times 1600 images to this video, which slows things up a little bit. So if we execute that again, it's still displaying our final image, and then if I pull up this output file, we can see the outsides of the image melting away to grayness while the interior center remains intact. And that is how you create my intro. Thank you for watching.